back to my channel. In this video, I am going to show you how to choose the correct method to solve modulus inequalities where modulus f of x is greater than or less than modulus g of x. In my previous video, I have shown you how to solve the other two types of modulus inequality. Did you watch it? If not, you can click on the link on top here to watch the video before you continue in this video. You can also find the link in the description. If this is your first time here, make sure you subscribe my channel by hitting the subscribe button below so that you won't miss any videos in future. If you find that this video is useful, then please give me a thumbs up. So let's start the lesson right now. In this video, I am going to show you how to solve modulus inequalities where modulus f of x is greater than or less than modulus g of x. Here I am going to use two methods. One is squaring both sides, one is graphical methods. Now let's look at this example. 2 modulus x minus 1 is less than or equal to modulus x plus 3. Since both modulus are linear, so now I'm going to square the both sides of the inequality. So now I get 4 multiply x minus 1 power 2 less than or equal to x plus 3 power 2. Now I'm going to expand the expression. Then I get 4 multiply x power 2 minus 2x plus 1 less than or equal to x power 2 plus 6x plus 9. Again, I expand the 4. Then I get 4x power 2 minus 8x plus 4, and I shift all the terms to the left. Then I get minus x power 2 minus 6x minus 9 less than or equal to 0. Then I'm going to simplify the expression. Then I get 3x power 2 minus 14x minus 5 less than or equal to 0. Then I'm going to factorize this quadratic expression, and I get 3x plus 1 multiply x minus 5 less than or equal to 0. To solve this inequality, now I sketch the U shape of this quadratic. And since the inequality is less than 0, so means the set of values of x that satisfy this inequality is from negative 1 over 3 up to positive 5. So therefore, the solution for this inequality must be written in set notation, that is x is in between negative 1 over 3 up to 5, included negative 1 over 3, included 5. Now I try to solve the same modulus inequality by using graphical method. First, I am going to sketch the graph of y equals modulus x minus 1. Now I start the graph from y equals x minus 1, which is without modulus. So the y-intercept is negative 1, x-intercept is 1. Then for the part of the graph which is below the x-axis must be reflected up by using x-axis as the line of reflection. So this part of the graph, we label it as y equals negative x minus 1. Since there is a 2 in front of the modulus x minus 1, so this means that all the values of y in this graph must be multiplied with 2. So after multiplied by 2, the y-intercept becomes 2. X-intercept remains the same. And when we compare the shape with the graph before, we find that the shape is steeper compared with the graph before. Now I'm going to sketch the graph modulus x plus 3. First, I start from the graph without modulus, that is x plus 3. The y-intercept is 3, x-intercept is negative 3. Then for the part of the graph which is below the x-axis must be reflected up by using x-axis. So this part of the graph is labeled as negative x plus 3. Now I'm going to put these two graphs together. So first, I'm going to label the x-axis and y-axis. Now I mark the x-axis and y-axis. Now for the first graph, y equals modulus x plus 3. So we take from this graph. Then for the graph 2 modulus x minus 1, we take from here. Now I'm going to label the graph. So for this one, this is y equals x plus 3. Now for this one, this is 2x minus 1. And for this one, this is negative 2x minus 1. And this is negative x plus 3. Now from the diagram, we can see that there are two intersection points between these two modulus. Now I have a question here. How do we know that there is an intersection point on the right hand side? And how do we know that there is no intersection point on the left hand side? When we look at the diagram, when the straight line below is steeper than the straight line above, then there is an intersection point here. When the straight line is steeper means the value of the gradient is greater. So therefore, when the gradient of the straight line below is greater than the gradient of the straight line above, then there is an intersection point here. Now we look at the straight line with the negative value of gradient. The negative value is just to show that the direction of the gradient is going down from left to right. Now to compare the gradient, the value of the gradient of this straight line is 2. and the value of the gradient of this straight line is 1. Now the straight line above is 2 and the straight line below is 1. Since the value of gradient above is greater than the gradient below, therefore there is no intersection point here. Now I'm going to find this intersection point. For the first point, that is the intersection between the graph y equals x plus 3 and also y equals negative 2 x minus 1. Now I'm going to do the simultaneous equation in order to find the value of x here. Now I get x plus 3 equals negative 2 x minus 1. Now I'm going to simplify this equation to get the value of x. So after simplify, I got the value of x is negative 1 over 3. Now for the second point, that is the intersection between the graph y equals x plus 3 and y equals 2x minus 1. So same thing, now I'm going to do the simultaneous equation. I get x plus 3 equals 2 x minus 1, and now I'm going to simplify to find the value of x. Then I get x is positive 5. Since the modulus inequality is 2 modulus x minus 1 is less than modulus x plus 3, this means that the graph 2x minus 1 is below the graph x plus 3. So when we look at this diagram, when x is less than negative 1 over 3, we can see that the graph x plus 3 is below the graph 2x minus 1. So this is not the section that we are going to take as the answer. Now we look at the section where when x is greater than negative 1 over 3 and less than 5. So we can see that the graph 2x minus 1 is below the graph x plus 3. So this means that this is the section that we are going to take as the answer. Then when we look at x, which is greater than 5, so we can see that the graph y plus 3 is below the graph 2x minus 1. So means this is not the section that we are going to take as the answer. So therefore, the correct answer for this modulus inequality is when x is greater than negative 1 over 3 up to positive 5. So therefore, we can write the answer in set notation, that is x is greater than negative 1 over 3 but less than 5, included negative 1 over 3 and included 5. Now let's try to solve this modulus inequality. When we look at this modulus inequality, we found that one of the modulus is non-linear, that is 1 over x. If the modulus is non-linear, then squaring both sides is not very suitable. Now let's try to find out why. If we use squaring both sides, then we get 2x minus 1 power 2 greater than 1 over x power 2. Now we shift 1 over 2 to the left hand side, we will get minus 1 over x power 2 greater than 0. Now we try to expand and simplify the expression on the left hand side. First, expand the 2x minus 1. Then we get 4x power 2 minus 4x plus 1. Then we expand again x power 2. Now we get 4x power 4 minus 4x power 3 plus x power 2 minus 1. So from here we can see that if we use squaring both sides, we will come to a polynomial where the degree is power 4. So to find the value of x with high degree of polynomial, the working step is complicated. So squaring both sides is not suitable for non-linear modulus. Since squaring both sides is not suitable, so now I'm going to use graphical method to solve this modulus inequality. So first I sketch the graph modulus 2x minus 1. To sketch the modulus graph, now I start from the graph without modulus, that is y equals 2x minus 1, where y-intercept is negative 1 and x-intercept is 1 over 2. Now this is the graph y equals 2x minus 1. Then the part of the graph which is below the y-x-axis must be reflected by using x-axis. So now this part of the graph I label as negative 2x minus 1. Now for the graph modulus 1 over x, same thing, I start sketching this graph without modulus. That is y equals 1 over x. This is reciprocal. Then same thing as the part below the x-axis. Now I'm going to reflect by using x-axis. So this part of the graph now I label as y equals negative 1 over x. Now I'm going to combine these two graphs in the same diagram. So first, modulus of 1 over x. Then this is y equals 1 over x. This is y equals negative 1 over x. Then followed by modulus of 2x minus 1. This is y equals 2x minus 1. And this is negative 2x minus 1. Now from the diagram we can see that there are two intersection points. For the first intersection point, that is the intersection between the graph y equals negative 2x minus 1 and the graph y equals negative 1 over x. So now I'm going to do the simultaneous equation in order to find the value of x of the intersection point. So first I need to simplify. So after simplify, I found that that is a quadratic. Then I try to factorize the quadratic. Then I get 2x plus 1, x minus 1. Then from here I can see that x is negative 1 over 2 or x is positive 1. Now for the second intersection point, the intersection is between y equals 2x minus 1 and y equals 1 over x. Same thing, I'm going to do simultaneous equation to find the value of x of this intersection point. Then now I get 2x minus x minus 1 equals 0. After factorization, I get 2x plus 1, x minus 1. So from here, same thing, x is negative 1 over 2 and x is 1. So we know that x negative 1 over 2 is the first intersection point and x equals 1 is the second intersection point. Since the inequality is modulus 2x minus 1 greater than 1 over modulus x, so means we are going to take the section where the graph 2x minus 1 is above and 1 over x is below. Now when we look at this diagram for the values of x which is less than 1 over 2, so we can see that the graph negative 2x minus 1 is above and negative 1 over x is below. So means this is the section that we are going to take as the answer. Now when we look at x between negative 1 over 2 up to 1, so we can see that the graph 2x minus 1 is below and the graph 1 over x is above. So this is not the section that we are going to take as the answer. Now when we continue, when x greater than 1, so we can see that 2x minus 1 is above and 1 over 1 is below. So this is the region that is we are going to take as the answer. So therefore, the set of value of x that satisfied this inequality is x less than negative 1 over 2 and x is greater than positive 1. So therefore, we can write the solution here in the set notation that x is less than negative 1 over 2 or x is greater than positive 1. So that's all for today. Do you understand what you learned today? Let me know in the comments below. If you find that this video is useful, hit the like button. Don't forget to subscribe to my channel. Thank you so much for watching. I hope you keep on learning and keep on watching my videos, and I hope to see you soon. Bye!